Hi dear students. So let us see this question that came in JEE Advanced Paper 2 Physics in the year 2022. This was a question from optics, and answer to this is a single digit integer. So if you get this right, you get +3. If you get this wrong, you get -1. Question is fairly simple, but there is one point that I would like to highlight over here, that in this case, the image, like we have to consider the motion along the x-axis only. However, the image can have velocity along the y-axis. The reason being, if you consider even a like very small object, like unless and until it is a point object, image will have some velocity along the y-axis. Okay, but we don't have to consider that, because if we start considering that, then we will need more data to solve this question. So in this question, J explicitly wanted us to consider the motion along the x-axis only. So I'll quickly tell you what is happening in this, and I'll brief you that what we would have done had we considered the motion along y-axis as well. Okay. So first, let us see quickly the data. In this, the object moves at a speed of 15 centimeter per second. Just a sec. Yes. And the mirror is also moving. The velocity of the mirror is unknown as of now. The focal length of the mirror is 10 centimeters. So we will put -10 because it's a concave mirror. And at the shown instance, value of u is 30 centimeters. Okay. So we have to find the velocity of the mirror so that image is at rest in the laboratory frame. That means in the ground frame. Okay. So we can use the mirror formula. It's a standard question. 1 by v plus 1 by u is equals to 1 by f. From here, you can see that 1 by v comes out to be 1 by f minus 1 by u, which means v becomes fu upon u minus f. Now, magnification is minus of v by u, which is nothing but f upon f minus u. Okay, so I have found magnification. I'll tell you why. Now, you can differentiate this equation. So again, we will get -1 by v square dv by dt. Okay, -1 by u square du by dt, right, equals to 0. So from here we can say that dv by dt. So here remember, v is the image distance from the mirror, u is the object distance from the mirror, and f is the focal length. Focal length is constant of the mirror, so it is not going to change. One very important point to note here is that dv by dt is the velocity of the image with respect to mirror, because v is always the distance from the mirror. Okay, from this point, pole. So remember, dv by dt is the image distance from the mirror. Okay, so dv by dt is the image velocity with respect to mirror. Okay, uh, like this. So v is the image distance from the mirror. So dv by dt will represent velocity of the image in the mirror frame. Similarly, du by dt will represent velocity of the object in the mirror frame. So this is the important point. So minus v square by u square du by dt. Okay. Now you can see that we can write this as magnification square. Okay. So that's why I had found the value of magnification as well. Now you can simply substitute the values dv by dt as we. So let's assume that mirror is moving towards the right direction with the value vm. Okay. So dv by dt will be velocity of the image minus velocity of the mirror. Correct? That should be equals to minus of magnification is f upon f minus u ka whole square into velocity of the object, which was given as 15 towards the positive side, because the object was moving like this, minus velocity of the mirror. Velocity of the mirror we have to find. Okay, velocity of the image is supposed to be 0, so we can put it over is 0 over here, minus vm. This focal length will be -10, and again this is -10. U ka value is -30 at the shown instance, so we will put this as -30. So this will become 15 minus vm, 15 minus vm, right? Now we can say that this is nothing but minus vm into this is -10 upon 20, so this will become -1 by 4, into 15 minus vm. So effectively this becomes minus 5 vm by 4, and this is minus 15 by 4. So here vm comes out to be 3. Since vm has come out to be positive, So we can say that mirror will go in the assumed direction. That means we had assumed Vm to be positive and it comes out to be positive. That means mirror will move in the right direction. Okay, if it had come out to be negative, then mirror would have moved towards the left direction. So this will be the answer to this question. Okay, now as I was saying that, see, image can have y velocity, but why image can have y velocity? Because here they have shown object to be having some height. Okay, so if you consider this top point, so let's say this at the shown instance is h1. Okay, at the shown instance, this is h1. Okay, height is h1. So we will put, like, we can assume that h1 is very very small. So we can say that magnification is nothing but height of the image divided by height of the h1. Okay, so we can assume that, at the shown instance, like, image must be forming somewhere. So from here, what you can do, you can differentiate this. So again, h2 is equals to h1 times magnification, which is f upon f minus u, right? So we can differentiate this. So dh2 by dt, dh2 by dt is the velocity of the image in the y-axis, okay, with respect to mirror again, okay, with respect to mirror axis, with respect to this axis, okay. So this is the velocity of the image in the y-axis, okay. So from here you can see that f upon f minus u into dh1 by dt, right? And we will differentiate this again. So again, h1 into f is constant. I'm differentiating using product rule. So f minus u ka derivative will be minus 1 upon f minus u ka whole square into minus du by dt. So this will again become plus. So now you can see, if we assume h1 to be very very small, then we can say that, like, if we put h1 to be 0, okay, then only at the shown instance ds2 by dt will be 0. dh1 by dt is 0. Why dh1 by dt is 0? Because the height of the object was not increasing. This is the height of the object with respect to the mirror. So this value is 0. Okay, and if we put h1 to be 0, if we put h1 to be 0 in this, then we will get ds2 by dt to be 0. So we have made an assumption that object is very very small. Then we can say that, uh, you know height of the image, sorry, velocity of the image along y-axis will come out to be 0. But again, since they had shown height to be like slightly of slight value, therefore, like, technically speaking, it will not be 0, but we have assumed like that. I hope you would have understood. Thank you.